polynomial which has a certain condition that it needs to be greater than 0, strictly greater than 0. That means it can't be 0, it has to be more than that. Okay, and we want to check how does the graph of this look like. Okay, not the precise one, but we'll see how does this graph look like. Okay, so first of all, if I say that this is my function f of x, so if that's the case, I can actually write f of x greater than 0, right? In other words, that's my given problem. Now, what does this mean graphically? What does this interpret? Anyone? Just give it a try.
Above the x-axis.
Very good. I think it's Daniel, right? Yeah. So very good. If you have a functional value more than 0, this clearly indicates your graph will be above the x-axis, for the given problem, right? For the given function of polynomial precisely. So it needs to be above the x-axis. So if you have a graph like this, all you're looking for is this area. Are you guys with me? Okay. Next, as we want to solve it, what do you mean when I say, or what do you understand when I say your functional value f of x is greater than 0? How do you interpret that graphically? So f of x, if f of x is greater than 0, graphically we mean then that the graph will be above the x-axis. Right, yeah. Okay. You wrote it wrong. Anyway, no problem. So you can still make the correction. Anyway, so all we are looking for is this area, right? Is this region above the x-axis. Anyway, as we are trying to solve it, that means we want to know the values of x for which this will be true, right? We want to solve it, and of course in terms of x, because we can see our variable is x, so we want to solve it for x. Okay, so first of all, if I rewrite my function, that's x plus 4 x minus 3 x minus 3, right? It's greater than 0. Now, as I need this strictly better than 0 or more than 0, that means two cases can happen. Okay. Now, what are the two cases? So if I say you have two different terms as a product, let's say A and B, and it's strictly greater than 0, is it possible to either of these to have a negative sign? Can you see what I'm doing here? Okay, the answer is yes, it could be, only if both of them are negative, right? Do you guys agree with me? Yeah. So that means the conclusion is your variable or your function, polynomial, whatever it is, both of these needs to be of the same sign, because the product of two negative functions will be positive. The product of two positive functions will also be positive. they can't be of a different sign, right? It is not possible for uh, A to be positive and B to be negative, or the vice versa. Both of these needs to be of the same sign, right? Okay, so if I say, I think I can make your life easier if I keep this one of this format. Okay, wait, is that x minus 3x plus 3, or does that only happen? No, it's all right. If you have confusion, you can always ask questions. So let me write the formula for you. So the basic formula is, if you have a, we use minus instead. A minus b, the quantity squared. That means you actually have the same item as a product of each other. But if you have anything of this format, the difference of this squared, then it's actually this. Okay. So I think we can keep the function in this format. It will help us simply because we know whatever the value of x is, whatever you take as x from the set of real numbers, even if it's negative, doesn't matter. This guy will always be positive. Can you see that? At least it will be non-negative, as long as uh, this squared sign works on it. Because whatever you take as x, this guy will always be at least non-negative. It could be 0. If you take 3 in place of x, it will be 0, but it will be never negative. Are you guys with me? Next, what about this guy? So as I know, whatever I take for this part, let me use a different color for it. Whatever I take for this part, I know it will, because of the square sign, because a positive exponent always makes your uh, function positive. Okay, it's not only for 2. It's true for all the even exponents. It's for 2, 4, 6, 8, and so on. Whatever your value of x is, the resulting value will always be positive. Anyway, so as we know, this guy is going to be positive, at least non-negative, as long as it's uh, more not 3, it will be strictly positive as well. But for this guy, we need to decide. So as I said, both of these has to be of the same sign. There is no way this guy can be negative. So what is the conclusion? Can you see where I'm going? Yeah, exactly. Very good. As I said, this can't be negative, so we can actually rule out this. This is not possible. So the only possible outcome here could be this, right? Both of them has to be positive. Now, very quick question. It needs to be positive, right? As Pearson said, what is the value of x which will keep this positive? Very easy question. Just give it a try.
-4.
Okay, I have two different answers, -4 and -3. Okay, so can anyone explain? The two of you have answered -3. Why is that -3? Okay, so this, yeah, so it has to be greater than -4, right? Why is that negative 3? I don't understand. So your entire, well, you can't really say that the only value is negative 3. That's not the case. Anything slightly, even slightly, yeah, exactly, as John said, anything slightly more than negative 4 will do, as John have written in a negative 3.9999, that will do as well. It's not exactly or precisely negative 3. I know what you are trying to do here, but for inequalities, it's actually slightly different the way it works for equalities or equations. So it needs to be just more than negative 4. And to answer the question for Pearson, uh, the entire functional value needs to be above 0, not your x. If your value of x is set up in a way which keeps your value positive, or rather more than 0, that's all right. We don't need our x to be greater than 0. We need the entire function to be greater than 0 instead. So x needs to be greater than 4, and it could be anything, just even slightly more than negative 4 will do. And one more thing we need to consider here is if x is, where is that? Here you go. If x is 3, can you see what the problem will be? Then the entire product will be 0. Can you see that? So x can't be 0. This guy will be non-zero for anything other than 3. It will be positive for any value other than 3. This guy will be positive for any value more than negative 4. So that means we can have a value of x less than, or I'm sorry, more than negative 4, but we need to stop at 3. We can't really take 3 because in that case our product will be 0, which we don't want. So we need to stop at 3, but of course we can take any values after that. So that means we can write like this, and it will be the union of these two. Okay, we are just excluding this guy 3 because it will make our product 0. So we'll go up to 3. We'll start after 3 as well. We'll just exclude that. Now, excuse me. Before we go any further, any question up to this? It's really important to understand it. This is the solution set, of course, we are looking for. We are trying to solve the inequality, and this is definitely the solution. Any question from this?
How does 3 make the whole function 0?
Sorry?
How does
okay. Okay, so if you plug in 3 here, what happens? Can you see? 3 minus 3?
Okay, 0.
And if you multiply anything by 0, the entire product will be 0 as well.
All right, I see.
Right? Yeah. Okay, very good. So this will be the answer. I don't understand how you solve it. Okay, which part? Eternity? Precisely which part you are struggling to understand? This one? Here? All of it? Oh my God. All right, let's give it a try again. So first of all, do you agree with me if I say that to be non-negative, both of these needs to be positive? Do you agree with me? Okay. So as we have an even exponent in terms of the function, or rather for the function, as you can see, we have an even exponent. This means, let me erase a couple of these because this looks clumsy. Okay, so this means this term here will always be positive, because whatever you take for x, other than 3, of course, because if you take 3, it will be 0. But if you take any value, even if it's negative something, say negative 100, even if you take that, this entire value will be positive just because of this even exponent. So does it make sense? I'll try to break it down into smaller parts so that you get all of this. Okay, so this is going to be positive for any value of x other than 3, because for 3 it will be 0, we know. So we'll try to exclude that. Other than that, everything will do. But we need to check values for this as well, because we don't want to take any value which will make this negative, because then the entire product will also be negative. If this is negative, this is positive, then the product will be negative, which we don't want. So we need to take care of this in a way so that it remains positive for a certain values of x. Okay, and if we solve it, we want it to we want it to be greater than 0. If we solve it, you can see if we change sides for 4, this will become a negative 4. So x needs to be strictly more than negative 4. So if you are still wondering what does this mean, if you take any value more than negative 4, sorry, any value more than negative 4, other than 3, of course, as I said, you can't really take 3 instead. Whatever you plug in here in place of x, it will always be greater than 0. You can just give it a try. Just take a value randomly from this, other than 3, and it needs to be negative 4. Just give me a number, and you will see the product will be greater than 0. Whatever you take. Negative 2, okay. Let's try negative 2. Negative 2 plus 4. Negative 2, negative 3 squared. Negative 2 plus 4 will be 2. And negative 3, negative 2 will be negative 5 squared. So 2 times negative 5 squared will be 25. It's 50, it's definitely greater than 0. As I said, whatever you take from the interval negative 4 to positive infinity, apart from the value 3, as long as x is negative, greater than negative 4, it will always be strictly more than 0, strictly greater than 0. Does it make sense now? Okay, very good. So, no problem. Sorry. So, this is how we write using the set notation. I'm going to rewrite it for you. So, we'll define x in a way where, x is strictly more than 4, but it will not really include 3 either, or it will be greater than 3 up to positive infinity. That's how you write using the set notation, right? But what if I want you guys to, I want you guys to write using the interval notation. So it starts from negative 4, ends at 3. All of both of these are not really included, as you can see. So it will be parenthesis, union, as we will have more than one set. We need to use that, or more than one union interval rather. It starts from 3, it goes up to infinity, right? So this will be using, this will be the solution using the interval sign. Okay, so keep an eye on the question. What does it require you to do? Whether it wants you to write using the set notation, whether it wants you to write using the interval notation, you need to write that. You need to see that very carefully, because even if your answer is right, if the question says write using the interval notation and you write this one, I don't think you'll get any point for that. Okay, the computerized questions are set up in this way. Anyway, so keep an eye on the question. And next, we want to see how does the graph look like. Very quick. We don't want to draw the precise graph anyway. And before that, let me use the space on my left to see what it looks like. Okay, and if I just write it in this format, sorry, I can clearly see I'll have 3 x's as a product. So if I pick a number greater than 3 is correct. Yes, of course. If you pick any number other than 3 up to infinity, it will always be positive. No doubt about that. You can always check that by plugging in different values. Yeah, sure. But of course, in maths, we want to solve problems with more accuracy and with probably less time. So we can always solve this type of problems by plugging in tons of points, you know, by picking up different values of x, plug it back into the main inequality and see which works and which doesn't work, but it takes a lot of time. So we want to develop a way which will save our time. That's how we can do. Okay, and sorry, I can see that this polynomial has 3 x's as a working as a product, right? So definitely I'll have a format like this, right? Can you see that? Because you can see 3 x's here, right? And the highest exponent is 3. So my intuition should say that it will behave like y equals x cubed. Do you guys agree with me? The end behavior, it will behave like x cubed. You have seen this, I think, in 4.1 or 2, right? So it will behave like x cubed. And yeah, of course, x cubed goes below the x-axis. We haven't gone this far. We'll actually go there. And we can actually see the x-intercepts as well. We'll have an intercept at -4, 0 from this, and at 3, 0 from this, right? And also, this one is a real 0 of multiplicity 1. So that means your graph will cross this point. Your graph will cross this point. And this one has a multiplicity of 2. That means even number. So your graph will not cross this. It will just touch that point and start going upward again. So we know the graph of x cubed looks like this, right? Something like this, if I remember. So your graph will look something like this. It will behave something like this. So let's set up the problem. It's 3, 0. It's -4, 0. Let me write it here. So it will come down to this. As I said, it will not cross the x-axis because it has a multiplicity of 2, an even number. So it will touch it. It will start going upwards. You can calculate the y-intercept by plugging in 0 in place of x. Let us do that as well. So if that's 0, we'll have 4. If that's 0, it will be -3. -3 squared will be 9. So it will be 36. So at somewhere here, sorry, somewhere here, let's say that's our point 0, 36, that's our y-intercept. It will cross that and it will come down like, oops, sorry. It will come down like this, okay? So that's how your graph will look like. But you only need the portion where this is strictly greater than 0. So this will be for this portion, okay? And for this inequality, this part won't be there, okay? But that's how the graph looks like. Any question from this? This is the graph for this polynomial. I haven't set up the inequality there, right? But if I set that, first of all, I have to see how the graph looks like. Then if I set the inequality, I know this will be this part. Sorry, not this one. It will start from here. It will start from this 4, -4 rather, and continue to this area, okay? Okay, so first of all, you won't be required, you won't be asked to draw this type of graph. But if you want to draw the graph, the best idea is to draw the graph for the function first, then set up the inequality. This will be easier to draw. But yeah, of course, if you straight away want to do that for the inequality, if you know how does this graph will behave, you can always eliminate the part which is out of your inequality. But again, you will not be asked to graph, but you need to recognize the graph. That means you might see a multiple choice question like this, okay? Okay, so this is the graph for a polynomial. Now we want to check what happens if we try to solve a rational inequality. I think to be accurate, we should. Well, again, if you are asked draw this, then yeah, of course, your graph will look like this. Of course, and you need to show by showing arrows that this is the region you are looking for. Okay, all this going to your right. You need to show that this way. Okay, so next we'll take example 3 and see how we can solve a rational inequality. So let's say my f of x is x minus 1 over x squared minus 9. Okay, and we want to solve the inequality for this. That means x minus 1 over x squared minus 9 will be greater or equal 0. Okay, we want to solve it for x. We want to see for which values of x this will be true. Okay, next, sorry. First of all, if we want to draw this, what happens? If you remember, let's say solve it using graphs. I'll actually show both ways. You can actually solve it without graphs as well. First of all, let's see what happens for this. What happens for to this inequality if we know how this graph look like. Excuse me. And if you go back to the previous lecture, we have actually drawn graph for this exact function, right? And the graph looks like this. If you don't remember, let me draw the graph for you. This will be the asymptote, vertical asymptote, of course. This will be the other vertical asymptote. If you remember, we spent a lot of time yesterday for drawing this. There will be another asymptote here at y equals 0. Okay, and your graph will behave like this. Sorry. Okay, this is how the graph looks like. If you go back to the lecture, I think it's the last one. Yeah, I think it should be on the previous lecture. You'll see we have a graph like this for this rational function, and we just from this graph we want to find the values of x for which this inequality will hold, right? So in your quiz, this graph will be given, so no worries about that. This graph will be given. I won't say you to graph this because that will be too much work, because this graphing needs a lot of time as well. So this graph will be given. All you need to do is to eyeball the values of x for which this inequality will hold. Now, as you can see the graph, let me write the points for you real quick so that you can decide for which part this hold. Yeah, now as you can see the graph, can anyone tell me the intervals of x for which this inequality holds? Just don't look at the answer on the file. Just look at the graph. Try to find the answer from this. No, that's not the right answer. Just think a little bit differently. You're walking in the right direction, but not quite. Negative 3 to 0, 3 to infinity. Yeah, very good. So I think I have drawn the graph just a little bit wayward. Let me make the correction. Let me see how does this graph look like. I have the file. I can see it here. Here you go. There is the file. Let me see how does this graph look like. Okay, yeah. So this is the graph. So I think we have the intercept at x equals 1, right? Yeah, so I think my graph was right anyway. So yeah, so it should be something like this. Yeah, okay. So definitely from 3 to infinity, the graph will be at least 0 or more, okay? Or as we have an intercept at 1, 0, So for this interval as well, oh, I think I can use a different color for it. For this interval up to this, at 1, 0, at this very point, our functional value is 0, right? Because we can see that 1, 0, that means our functional value is 0. So we can include that because our inequality says we can take 0 or more. So up to -3 to infinity, yeah. So the answer should be -3 to 1. Oh, sorry, I can't include -3 because it will never reach -3. And it will be 3 to infinity. Once again, I can't really include 3. As you can see, 3 is an asymptote. So this will be the answer. Okay, if the graph is given, the rest is very simple. But yeah, you need to be careful about this sign, about this inclusion or exclusion. If you make one mistake out of this possible 4, I don't think you'll get any credit for that.
Is it
Okay,
-1 or 1?
Sorry.
From -3 to 1 or from -3 to 1?
Oh yeah, it's 1. It's sorry. Yeah, it's definitely 1. Yeah, of course. It's definitely 1. You can see that here. You can see that on the graph, right? So that should be your answer. So if it was in-person class, I would have said that for x minus 1, x squared minus 9 greater or equal 0, I would have said solve this by using graph. That means you would have been asked to draw the graph first and then eyeball the answer. But for this online class, I think I'll avoid that. I'll give you the graph. What I want to do, what I want you guys to do is to see what the solution could be. Or I could say solve it algebraically, which I'll show right after this. Algebraically, you can solve it without going for the graph, okay? Okay, so what should we do? If we want to solve it algebraically, our function is x squared minus 9, right? Yeah. Okay. Excuse me. And let's say we don't have the graph. We don't want to spend too much time on graphing. We just want to solve it using our algebraic concept. Okay. Now what should we do? So first of all, we want to see the intervals, right? And if you remember from yesterday, if you don't remember, let me remind you, our zeros are at x equals 1 for the numerator, and the zeros for the denominator is at x equals 3 and -3, right? And we subdivided these zeros into, as we have 3 zeros, we subdivided these into 4 intervals, right? We started from -infinity to -3, -3 to 3, sorry, -3 to 1, rather, 1 to 3, and 3 to positive infinity. Do you remember this? First of all, before we go any further, do you guys remember from the last lecture? We can subdivide our entire real number set of real number by excuse me, by rewriting like this. Okay, now how can we use this to find our result? How can we use this? And the answer could be found out just the way we have done. Right, very good, very good. We just need to take a value from each of these intervals, and then we can decide what happens. I'll come to that later. So let's take one value from each. I think I have the values in my previous file. So without wasting any time, let me go there and pick up the values. Okay. So, okay. So yeah, we can use this instead. So for -4, our functional value is negative, right? Can you see that? Okay, let me copy this real quick. So -5/7, +1/9, -1/5, and +3/7. Let me copy this real quick there so that we can use that file later on when I'll share that with you guys. 5/7, 1/9, -1/5, and 3/7. Okay, so let me rewrite the file values here rather. So let's take -4 here, and -4, that's my x, that's my functional value, of course. If I pick up -4, the functional value will be -5/7. If I pick 2, the functional value will be 1/9. If I just replace your values in place of x, okay? If you're still wondering how am I getting this, I'm just replacing my x by these values. And in return, the function gives me these values, okay? If I pick up, oh, I think I have picked up 0 here, not 9, not 2. So if I pick up 0, if I pick up 2 here, I'll get a -1/5. And if I pick up, let's say 4, I'll get a 3/7. Okay. Now, how can we find the intervals for which this graph, or rather this inequality, will hold? So we know the intervals. Now we need to pick up the intervals for which the inequality hold. So our inequality had 3 terms, okay? And it strictly wants us to get the values 0 or more, right? The final or the resulting value. And if the entire value is 0 or more, that means non-negative, that means at least one of this is true. That means all 3 will be positive, or if you have a negative value, at least 2 will be negative, and the other one, not at least, the 2 of these will be negative, and the other one will be positive. There is no way it will give us a non-negative value if you have just a single negative term here. Can you see that? Excuse me. So that means we need to have all positive values, or 2 negative and 1 positive value. And fortunately, we don't need to require this, or we don't need to check this, because we can actually see the functional value here by plugging in different values from the intervals. And as far as I can see, for these two, your inequality holds, right? This is the basic idea, by the way. But for this problem, you don't need to check that, because you already have the functional value. And as I'm repeating myself, only for 2 of this, you have a positive value. So clearly, your answer would be this interval and this interval. So it will be -3 to 1. And it will be 3 to infinity. Okay. Now, you can see our answer is slightly different than the previous one. Can you see can you eyeball the difference here? That's the previous one from the graph. And that's the one we have got solving it algebraically. Yeah, because in my intervals, I have used brackets, right? But as I'm looking for even a value of 0 or more, if I plug in x equals 1 here, I can see the numerator will be 0, and anything you divide, or rather, if you divide 0 by anything, it will always be 0, right? So that means we can actually conclude that we can include this one. So even algebraically, we are getting the same result. From the intervals, that's the difficult part. You might leave it here and get penalized because your intervals will always have brackets. If you have greater or equal, less or equal problems like this, you can always check by including that value, whether it satisfies or not. And on this occasion, you can see it satisfies the inequality, so you can actually hold or rather include that particular value. So that's how you can use the graph, or you can use these intervals to solve a rational inequality. Any question from this? Because this will be the last thing we'll be discussing from 4.5. After that, we'll actually go to the review section. Okay. If you have any question from this, you can go for it. Okay, so it looks like no question. So we can actually start reviewing stuff for the test. Let me use a different file, and it will be the review. Okay. And it will be heading. Okay. So from the review section, if you have any particular question you want me to solve, you can do that. We still have one more day for that. No worries. We'll go for review tomorrow as well. So if you have any question, you can discuss it tomorrow, or even you can send me emails regarding that. But right now, if you have any particular question you want me to solve, you can go for that. Anyone, any question? Yeah, sure. Just take a minute or two. And if you have any question, you can go for that. 7 on chapter 3. Okay, let's try that. 7 on chapter 3. So chapter 3, what is that? That is chapter 3. Okay, so the question says, if you have that in front of you, complete parts A to D for the functions f of x equals, let me write that, chapter 3, problem 7, f of x is negative x, or negative x squared rather, plus 9, and g of x is negative 2x plus 1. Okay, and the question says, first of all, graph it. Okay, the first thing is to graph it, and for that graphing we'll use the transformation. Okay, so let me show real quick. We know the graph of x squared will look like this, right? What about the negative x squared? If you remember, if you put on, or rather a plug in a negative in front, it will actually, sorry, it will actually yeah, it will give you a mirror image of or rather with respect to the x-axis. Okay, okay, so that's your graph for y equals negative x squared, but that's not yet done. We need to do one more thing. We have a plus 9, so yeah, that's right, we need to go up by 9. Let's say that's my 9. So now the graph will look like this. Sorry, the graph will look like this. Okay, it doesn't look good though. Let me try to do it more convincingly. I hope this is enough convincing. So this will be a graph for x squared plus 9. So the first job is done. Okay. Secondly, I'm going to quickly remove this, so you can remember it. Okay, because I'll need more space. So I'm going to remove the other parts apart from the original one. So that's your graph for f of x. Now we'll repeat the same process for the next function. Okay, so we know the graph of y equals x looks like this. Now, how does the graph will look like if we multiply it by a 2 first? Let us do it one by one. If we want to multiply it by a 2, what will happen? So if you don't remember the stretch or the compress, as you can see, if you have y equals x and y equals 2x, whatever your value of x is, you can see for the second one, your functional value will be 2 times bigger, right? So it will stretch. Of course, it will stretch by 2. So it will look like this. Okay, sorry. It will look like this. So this will be y equals 2x. Okay, and now we have a negative 2x. So that means this will actually get flipped, okay? This will y equals negative 2x, okay? And finally, we have a plus 1. That means it will go up by 1, right? We'll have a vertical shift by just 1 unit. And that means this will go like this. So this will be your graph, okay? And to make things clear, I'll once again remove this other stuff from here apart from the main function, okay? So this will be your graph. And as you can see it, let me check which option it is. Definitely not A. It can't be B. Looks to me it's C, right? Let me see the answer. Yeah, it's C. As you can see, it's option C. Any question from this? Okay, next. It says solve the set, or rather solve for f of x equals g of x. So that's part 1. Part 2 says solve when f of x equals g of x. And it's really easy. We have seen this in math 95, 96. We just need to plug in and solve it for x. So negative x squared plus 9, g of x is negative 2x rather, plus 1. If we solve it, we'll get the result. So negative x squared, this, if we change sides for this, it will be positive 2x. If we change sides for this, it will be negative 1. So 9 minus negative 1 will be 8 equals 0. And we know the ideal formation is this, right? So what we'll do, we'll multiply each side by negative. So that means all these signs will get altered if we multiply both sides by something negative. So x squared minus 2x minus 8 equals 0. And if we use the formula, x equals negative b plus minus b squared minus 4ac, square root of b squared minus 4ac over 2a, where a is 1, okay? We have nothing in front, that means that's 1. B is negative 2 and C is negative 8. If we plug in that, let's see what happens. So negative and negative 2 will be a positive 2. Negative 2 squared. Negative 4, A is 1, C is negative 8. 2 times 1. So it will be a positive 2 plus minus square root of 4. This negative and negative will be positive. 4 times 8 is 32 over 2. 2 plus minus 4 plus 32 will be 36. Square root of 36 is 6. So we'll have 2 plus 6 over 2 or 2 minus 6 over 2. So x will be 2 plus 6 is 8. 8 over 2 is 4. Or x will be 2 minus 6 is negative 4. And negative 4 over 2 will be negative 2. So your set of solution will be negative 2 and 4, and this will be your answer. Any question from this? This will be your solution set, right? Okay, next one, part 3. Where is that? Okay. Use the result of part B to label the points of intersection of the graphs of f and g. The point of intersections are, okay, and for point of intersection, you actually need 2 coordinates, right? One from the x, second from the y. Fortunately, we already have one from part B, as the question said, because we are solving it for f of x equals g of x. That means this is this graphically means the points where it actually intersects each other. Okay, the lines intersect each other. This is what it means graphically. If you set this to equal, this means the points where these 2 graphs will intersect each other. So that means we already have the value of x. All we need to do is to find the corresponding value of y, or the functional value, right? Now, how can you do that? So we can plug in, let's say, negative 2 times 4 plus, what was that, 1, plus 1. So it will be negative 8 plus 1, negative 7. So one point of intersection will be negative 4, negative 7, right? And the other one, let us write y1 and y2 to distinguish the different result. So it will be negative 2. This time we'll plug in negative 2 in place of x, plus 1, positive 4 plus 1 gives us a 5. So it will be negative 2, 5. So this is your answer. These are not intervals, by the way. These are set of points, ordered pairs, okay? X coordinates and y, x coordinate and y coordinate. So this will be your answer. Any question from this? Okay, no question. Number 4.
Can
Yeah.
we use the graph to determine the points that are equal? Like,
Sorry, do you mean you want to use the graph to find the intersecting points?
yeah.
Well, if the graph has precise points, you can do that. But in the options, I don't see. I don't understand. I don't think that you'll get that precisely, because the graph is too small, as you can see. You might get a wrong answer if you want to do that. You can always do that if you have a bigger picture of it, okay? But if you want to do this from this graph, you might get a wrong answer. I'm not sure, because to me, the pictures look really small.
Thank you. I got it.
No problem. But yeah, of course, if you can eyeball that from the graph, that's even better. Of course, as a mathematician, we want, as I said, we want to save time. We want to do it with more accuracy, and we want to do this consuming less time. Anyway, Part 4. Shade the region for which f of x is strictly greater than g of x. Okay, now as I said, if you remember, if I write anything like this graphically mean your graph of this function will be above the graph of this function. That's the graphical interpretation, right? We have said this at the beginning of today's lecture. So if we want to see the region, the area where this inequality holds, all we need to do is to look at the options. If we might have more than one, I'm not sure how many we have here. I'll soon see. But all we need to check is to see where the graph of this function is actually above the graph of the other. So we have the graph here. We can use this, okay? And if I use a different color, let's use red. All I can see, this is the graph for f of x, right? And this is the graph for g of x. So the only region I can see where this graph of f is above this graph of g is this, what color is that? I guess that's violet. Anyway, whatever that is, only in this area. As you can see, my blue line is above the yellow line, only in this shaded region. Can you see that? So if I look at the options, yeah, I can see only one option like that. And to me, looks like it's option C. Okay, so for 4, it's option C as well. Okay, so that's question 7 for you. Any question from this, or if you want to start a new question, you can write that as well. Still have plenty of time for at least one more question. No more questions from this. So any other question from the review materials? Excuse me. Number 8, chapter 3. Okay, the very next one. Okay, let's try this. So it's number 8 from chapter 3. Okay, David has available 80 yards of fencing and wishes to enclose a rectangular area. So we have a rectangular area and express the area A of the rectangle as a function of the width W of the rectangle. Okay. And for what value of W is the area largest? What is the maximum area? Okay. So first of all, we know that formula for the area is length times width, right? But in problem A, they said you need to write the area in terms of W, where W is your width. So what does this mean? Can anyone think what it actually wants you to do? What does your intuition say? Okay, no problem. So the thing is, you want to replace the value of L by W. Okay, that means you want to find the relation between L and W, and then you want to substitute that L, okay, by something, some related value of W, okay. And now for that, all we want to do is we want to find the relation of L and W. And for that, we have a clue. The question says, David already has a fencing, let's say like this, because we only do fencing on the sides, not inside, okay? Only on the sides, only on the green shaded region, okay? That means only in length and width, right? And it's, I think it's 80, right? Let me quickly go back to the question. Yeah, it's 80. So we know the perimeter of a rectangle is this, and we have a fence around this perimeter, which is 80 meters, right? Or 80 yards, whatever. So 80 yards. So that means our perimeter is 80 yards. And from this, we can actually, oops, sorry, I think I should use capital W here because they have already mentioned that. And for convenience, let me use capital L as well. It will look better. It doesn't mean that you need to do that anyway. So from this, we want to substitute the value of L by W, right? So 2L will be 80 minus 2W, and L will be, if you divide both sides by 2, it will be 40 minus W. Okay, so that's your L. And now if you substitute it in the formula, L will be 40 minus W times W. So it will be 40W minus W squared. And this is your area in terms of the width. Okay, so that's part A. For B, it says, for what value of W is the area largest? That means we are looking for the highest value, the largest value of this. How can you do that? Just give it a try. How can we find the largest, find the value of W? We're looking for the value of W, which will give us the largest area. How can we solve it? Solve the value of each side. I didn't understand. Can you please tell me precisely? Solve for W instead of L. Solve which part, or how can we solve it? This is the most important part here.
I think since we have now the value of L and expressed as W, we can use it in the perimeter to solve it.
Do you mean here?
Yeah, now we replace L by, okay.
Okay, let's try this. Let's try this. The best thing as a mathematician is you try and, we say that try and error. That means you try, you find an error, and you try again with something new, okay? That's one of the core things of math. Anyway, so.
Okay. I've seen something. Does it say like we find the side with the maximum area?
Yeah, the question says, for what value of W is the area largest? That means, yeah, we are looking for the value of W.
Okay, so I think we are looking for the vertex.
Looking for the what? Sorry?
Vertex.
Vertex. Yeah, very good. Yeah, very good. Because simply, if you remember, for a function, we have a maximum value at the vertex, right? To remember. And what's the formula for the vertex? Anyone? Really quick. Negative b over 2a. Very good. Negative b over 2a. What's the value of b and a here?
40W.
Not w, Daniel, because we
Okay.
actually want the coefficient, not the variable itself.
40,
right?
Yeah.
Okay. So b will be 40. And what's a?
-1.
-1. Very good. You guys are doing really good job. So it will be -40 over -2, 20. So that's your answer. Okay. Does it make sense?
Yeah.
Okay. As you can see, if you know the formula and if you know what it actually wants you to do, that means if you know that you actually have to find the vertex, and your vertex, the formula for the vertex is this, you can see it shouldn't take you more than 30 seconds. Can you see that? So the main thing is you need to understand what the question wants you to do. Okay, the rest should be very easy. Anyway, so we have the value for of W. Next, they say find the area, of course. Yeah. So now we can actually plug it back here. 40 times 20, 20 squared. So 40 times 20, I think it's 800, right? 4 times 2, yeah. 820 squared will be 400. So 400. That's the largest area. Okay. And that's your answer. Okay, we still have, okay, Pearson. So the basic idea for, how the vertex comes is if you have a format like this, the coefficient of the term with x gives you b, and coefficient of the term with x squared gives you a for the variable x. And on this occasion, our variable is w. Okay. Okay, so I think we still have a couple of minutes to go for a short question. If you have any preference, you can go for that. Otherwise, I can show one randomly, because we have 5 more minutes before we wrap it up for today. Okay, so okay, let me show a problem like this. You will definitely find at least one question like this. I'm actually disclosing the question for you. You will have a fraction, and you will be asked to find the domain. Okay, you will definitely have a question like this. So let's say, let me show a complicated fraction. Okay, so if I say x squared plus 5 x plus 5. Okay, what should be the domain of this? You will have a blank. You just need to fill it in by the right with the right answer. as you can see, if you know the concept, it will take about 30 seconds to complete, as long as you're confident about your concept, right? So who can tell me the answer real quick? And why? Why do you think set of all real numbers should be the domain? Because the graph 1 over x goes from, no, that's not a right logic, because for that means for any graph, as the reason, the logic you are saying, for any graph, for any fraction of this format, let's say this, it looks like the same, right? For any graph, it will be from negative infinity to infinity, but that's not the case. Although your answer is right, but your logic is not. So you might get uh, penalized, by using this logic if you use. So if you remember, for the fractions, all you need to do is to set your denominator to 0 and find the values of x for which this is 0, and apart from those values, everything else from the set of real numbers is your domain. Okay, so if you set your denominator to 0, I can see x squared is negative 5, which is not possible. That means there is no value of x for which the denominator will be 0. That's why we can say set of all real numbers is our domain. Using the same concept, if we solve it for here, solve it for this one, x squared minus 5 is 0. X squared will be 5. If we solve it, taking square root on both sides, we get x equals plus minus 5. That means it will be from negative infinity to negative 5, from negative 5 to 5, 5 to infinity. That means, or in other words, you can write it this way: x not equals to 5 and not equals to negative 5. Or you can write a plus minus 5 here, whichever you like. Okay, so for a fraction, oh, sorry, yeah, root 5. Yeah, very good. Sorry, not here. It should be here. Yeah. So whenever you have a fraction, you need to set your denominator to 0 and see for which values of x your denominator becomes 0. And apart from those, everything else will be your domain. Okay, when you type it on MML, can you use the plus minus 5 there? Well, I'm not sure. So, because of course I don't really use MML as a student, so I can't really see what happens from your point of view. So I'd suggest you guys to avoid anything that that's not clear in terms of the policy they have. So I think you might avoid that. So for the question, when I set up the question, I have actually proper instruction. So if you have more than one like this, I've said write using comma or write using that and that. If you see the question, you should be able to answer it better. Okay, so that's it for today.